Okay, I hope you enjoyed the 4.0 just preview of trigonometry. It's one of my favorite topics. So here we're going to talk about special angles in 4.1. So special angles are based on two triangles. And these two triangles I'm just going to write out. Again, I'm not going to prove why they exist like I usually do in class. And here I have a list, a chart with sine, cos, and tan of every special angle. 30, 45, 60, and I've also included 0 and 90. Every multiple of these angles is fair game in this chapter. Okay, but as long as we know these basic ones, we know all the multiples of them. Okay, and I'm going to explain how. So our first triangle is a regular 1, 1, root 2 triangles, where these angles are both 45. Okay, the second triangle is a 30, 60, 90. Okay, and this is going to be 2, root 3, 1. Now you have to memorize these triangles. These are the triangles where you acquire your special angles from. So without memorizing these triangles, you will not be able to find the exact values of questions in this chapter. You could memorize this chart, which would be very fast. But I don't like depending on memorization, especially in math. We should be able to develop our own numbers, really. Okay, so let's take a look at what this means. So here I have 45, I have 30, I have 60, I also have 90. But the 0 and 90, I don't like to look at triangles to figure out these answers. So let's do the 0 and 90 first from 4.0. 0 degrees. 0 degrees is here. Okay, I'm rotating around that unit circle. 0 degrees is perfect horizontal distance. So sine, the vertical distance, is 0 here. On the other hand, cos is 1 because there's full horizontal distance here. Tan is sine over cos. 0 divided by 1, 0. So that's easy. Let's go to 90. Sine of 90. Yep, that's vertical distance of 1. Cos, that's horizontal distance. There's no horizontal distance in 90 degrees, so that's 0. 1 divided by 0, 0? Absolutely not. This is undefined. You cannot divide by 0. If you put a 0 there, you're wrong. Okay, let's look at these other ones now, 30, 45, and 60. So for 30, I'm going to look for the 30. And I'm just going to find sine of 30 using SOHCAHTOA. Sine is opposite over hypotenuse, 1 over 2. That's it. Cos of 30. Adjacent over hypotenuse, root 3 over 2. This divided by this, I don't know if you know this, but if you're dividing two fractions that have the same denominator, you just divide the numerator. So this is 1 over root 3. Okay, let's go on to the 60 just because it's the same triangle. You're going to notice, obviously, they're going to be opposites because I'm using the opposite angle. So sine of this angle is the same as cos of this angle. So sine of 60 is opposite over hypotenuse, root 3 over 2. Cos of 60 is 1 over 2. Okay, and tan is root 3 over 1, or just root 3. Again, I'm dividing these two. The denominators are the same, so root 3 over 1. Now, let's take a look at this 45. Both of these are 45s. Doesn't matter which one I use. Sine of 45, 1 over root 2. Easy. Cos of 45, well, it's going to be the same, 1 over root 2. This divided by this, 1. So in this table, I've discovered every single every single special angle from these special triangles that I'm going to use to find the exact values of 0, 30, 45, 60, 90, and any multiples of these. Yeah, one last thing I'm going to go over is I'm going to explain these values 1 over root 2. Right here, because your calculators might be giving you a different answer. So let's take the number 1 over root 2. In math, we don't like having a complication on the denominator. It makes things difficult for us. So we like to rationalize the denominator, and that means getting rid of the root from the denominator. So how do you get rid of that? Well, I know for sure that if I multiply root 2 by root 2, guaranteed the root's going to be gone, because technically what I'm doing is I'm squaring the square root. So this is what I'm going to do. I'm going to multiply it by root 2. But I can't just multiply by root 2 in the denominator because that's going to change the value of this number. So I multiply it by a value of 1 in a way that can also rationalize the denominator. So I multiply by the conjugate, root 2 over root 2. Now, what's this going to do? 1 times root 2 is root 2. Root 2 times root 2, 2. This is the same as this. Your calculator will probably give you this as an answer because this is a better answer. We get 1 over root 2 straight from our special triangles. But if your calculator says root 2 over 2, this is technically more correct. Okay, we don't like roots on the denominators. Eventually, you're going to learn next year, we're going to have full polynomial functions in the denominator that are complicated. And our first goal is always to uncomplicate the denominator because it's hard to move from here. It's easy to move from here, easier. Okay, so just the difference in these values.